Good morning, everyone. We are moving on to our 7.2. We actually have a pre-section 7.2 as it turns out. I am in the skinny packet and I am on page 22. So if you want to get into the skinny packet, page 22, that is where we're going to start. So some of the things that we're going to talk about today are just some basic exponent rules that you did learn in middle school. And there's three of them that are pretty important. And hopefully we are covering all of those exponent rules. So let's go ahead and get started. Again, page 22 in the skinny packet. So what we're going to talk about is, just reading what's at the top, is that a power is a to the n, where n is bigger than 0. Now, it is possible that n might be smaller than 0, a negative number, but just understanding the parts, a is called the base, n is called the exponent, and we're going to use the rules of exponents to start simplifying them. Right? Because we have a lot of things that can simplify, like multiplication is a shortcut for adding the same number over and over again. And so what exponents do is a shortcut for multiplying the same number over and over again, or even dividing the same number over and over again. So that's what we're going to take a look at. So let's take a look at our first example. What happens when I have a common base? Okay, so notice my base is x or 4, and then I have my exponent. So remember, x cubed is just a shortcut for multiplying x 3 times, and then x to the 4th is a shortcut for multiplying x 4 times. So if this is a shortcut for multiplying x 3 times, and this is a shortcut for multiplying x 4 times, then I can take that idea and realize, well, that if I'm multiplying x 7 times, I can just write it like that. All right? So what this one is, again, x 5 times, and then we have another x, but just once. And just a reminder, if you don't see an exponent there, like what I said in the last chapter, is there's an understood 1 there. And so when I look, I have a total of 6 x's that are multiplying. And it doesn't matter if the base is a variable, a letter, or a number. This says I'm multiplying for 2 times, and then this says I'm multiplying for 3 times. So why not just multiply 4 5 times and write it as 4 to the 5th power? Now, it did say do not evaluate. We're not going to take the time to find out what 4 to the 5th power is. All right, so what could we do from this to this without having to write it out? And if you notice, jumping from here to here or here to here, that if we're sticking with the same base, right? X's to x, 4 to 4. But what we've done is we've added the exponents. So what can we do to go from, something that's in expanded form to the simplified form? That's what this is asking. What we can do is first we just keep the same base. And then we add the exponents. And so this seems to be pretty simple when your base is a letter. But when your base is a number, what I often see is people will still add 2 and 3 and make it 5, but they still want to go back to what we've done before and multiply 4 times 4 and make it 16. So it turns into 16 to the 5th power, which is a way, way different meaning than 4 to the 5th power. This is 4 multiplying 5 times, which is a very different amount than you multiplying 16 5 times. So you want to keep the same base and then add the exponents. So if we're going to do that, we can make a rule that you should be already familiar with. It's called the product rule. And it is, if you have the same base and they're multiplying, you can just add the exponents. All right, so let's take a look at this one. Would this work for this one? And the answer is no, because this means I'm multiplying 5 4 times, and then this one means I'm multiplying 4 2 times. So when I'm trying to put, a common base, I can't do that because I'm not multiplying the same thing over and over again. So there's no way I can make this something to a 6th power because there's not a common base happening. All right? So no, it doesn't. You have to have the same base. So let's just do a little bit of practice. Instead of writing it out, we're just going to follow this exponent. So we're going to start out pretty simple and then work our way into slightly more difficult problems. So when I look at this, I have the same base. This is 12 x's. This is 17 x's multiplying to each other. So I realize, hopefully, that that can just be 29 x's multiplying to each other. And this one is just written a little differently. It's in parentheses, which still seems or means multiplying. And instead of multiplying 2 things, we're multiplying 3 things. But it's all the same base, so I've got 2 and 4, which is 6, 6 and 7, which is 13. When you have something like this, and although we probably don't need to do it here, we're going to do it for this problem, so I want to start doing this, is we can kind of like just organize this and make it, instead of kind of a bigger problem, make it into smaller problems. So what would happen here, what I like to do is make houses. And so I draw a wall, like that's the wall in between the rooms, and I put the common things in one room and the other common things in a different room. So technically this is 2 times x to the 4th times 5 times to the x. And what I do is I take the numbers, so remember the numbers in front of the variables are called the coefficients, and I put them in a room, and then I take the variables, as long as they're the same variable, and I put them in the same room. And again, remember there's just a first power there. And then I look at this as 2 little problems. 2 times 5 is 10. And when I look over here, I have 5 x's. Same thing here, it's just in parentheses. So if I separate this out, I'll put my coefficients in one room. Whoops, and it doesn't matter which order I put them. And I'll put my x's in another room. And then I can think of this as one little problem, negative 2 times 3. And when I add these up, I've got a total of 6 x's. So going with that, that makes a challenge problem like this a lot easier to deal with. So if you notice, again, when I start to do this, I want to think about how many rooms I would need. So I need a room for my numbers, so 2 and a 4 and this negative 3 and this 5, which I'm running out of room, so I'll put it into the front. And then I'll put all my negative or all my exponents with x's in the other room. So x to the 3rd, x to the 4th, and x to the negative 3rd. And then I have one little problem here, one little problem here, and I'm done. So this is 10 when I multiply. This is negative 12. And when I multiply those two numbers, I get negative 120. And then as far as my x's, when I add them up, you know, I don't know if this would be good just to add left to right. I would hopefully, you would see that 3 and negative 3 would cancel each other out, and we would just be left with x to the 4th. So if you have the same base, you can add the exponents, but you keep the same base as you go along. So now let's take a look at what happens if you divide. So we're going to go into expanded form first, and again, this just means I have all these x's on top. I have 7 of them, and then I have 3 on the bottom. And what we can do is, because these are multiplying, I can start to take out common factors. Remember from our last section that terms are separated by addition subtraction signs, but factors are things that are separated by multiplication signs. So what I can do is start taking out a common factor. Those can go out, those can go out, those can go out, or as we like to say, cancel out. And when I'm done, I realize I have 4 x's on the top, so x to the 4th. On this one, kind of changes. And now when I take out 3 of them, I have 4 x's, but they're in the bottom. And to show they're in the denominator, I need something in the numerator, and we'll just put 1 in there to show that, you know, it's 1 over x to the 4th. When you start to put numbers in there, again, you can kind of do what I did before. I'm just going to make a wall for my house, and I'm going to put my coefficients in one, and I'll put all the x's in the other. 5, 6, 7, 8, 9, 10, 11, and then down here are 6. So first, I want to remember that this is 18 divided by 6, which is 3. So when I'm done, I have 3 as an answer. And then when I start to take out common x's, common factors, I'm left with 1, 2, 3, 4, 5 x's. And it will be in the numerator. 18 divided by 6 would also put 3 in the numerator. So here when I do this one, again, it doesn't matter if it's variables or numbers that are to an exponent. This is 4 4's in the numerator, 2 4's in the denominator. So when I'm done, I have 4 to the second. And it's great if you know that 4 to the second is 16. That's not our focus right now. So what we want to do now is just look, is there a shortcut? So can I go from here to here or here to here? And you can. What you want to do is, so actually we're going to skip this question. How could one go from the expression to the simplified form? And how do I go from here to here? Well, you'll notice I've kept the same base, okay? And then I've subtracted the exponents. So again, you want to keep the same base. And then you want to subtract your exponents. Okay? So if we look here, our rule that we'll do is x, because it's the same base, and then I can just subtract the exponents. What you're going to have to think about is when you're done subtracting, you know, when we did our canceling up here, sometimes our x's were in a numerator position and sometimes they were in a denominator position. So if you look at this, you know, and I wrote this out, I've got 12 x's on top and 7 on the bottom. So what I'm going to do real quick, and I didn't mean to make a fraction bar that long, I don't know what I'm doing, is I can just subtract those exponents. So 12 minus 7 is 5. So the question is, where are those 5 x's? Because I've got two places where they could be, in the numerator and the denominator. And if you think about this up here, when we subtracted and got 4, where were those 4? They were in the numerator, and it's because when I started, I had more in the numerator than I did in the denominator. So when I cancel the same amount out, the extras that I'll have will be in the numerator because I had more to start in the numerator. And then down here, when I had 3 x's in the top and 7 in the bottom, and I canceled out, here I could still subtract 7 minus 3, but now my 4 are in the denominator because I started with more in the denominator. And when I cancel out, that's where the extras will be in the denominator. So when I subtract here and I get 5, I have to realize there are more x's in the numerator to start with. So that is where my answer is going to start with. And I could write it like that, but traditionally we do not put the 1 in the denominator because anything divided by 1 is what you started with. So here when I subtract, you know, I don't want to necessarily do 3 minus 19. I'm going to do 19 minus 3, which is 16. And then I think about where those 16 x's should be. They should be in the denominator. But I need a numerator, so I'll put 1. Here we're going to go back to those houses. So I'm going to put my coefficients in one house. And I'm going to put my x's in another house. And what I don't want you to start to get confused with is that when I deal with the x's, and again there's a 1 there, when I subtract these, I have 4 left in the numerator because I started out with more x's in the numerator. I don't want you to start, because we're subtracting these, to subtract these. This is, before we ever learned about exponents, this is 18 divided by 3, which is 6. And again, there could be a 1 here, but we usually don't put 1 in the denominator. All right, last one. So again, I'm going to put my coefficients in 1 and my x's in the other room. And now when I go to subtract the x's, 5 minus 2 is 3. I will have those 3 x's in the denominator. And then again, I want to think of this as 3/9. In 3/9, we would find a common number to divide out, which is 3. So when you divide each of these by 3, you're left with 1/3. So that gets to be tricky. People want to subtract these, so they want to subtract these and then have 6 and then put 6 in the denominator. But exponent rules are different than just regular rules of base numbers, I should say. So let's try our challenge problem. So I've got numbers and x's. So I'm going to put my numbers 2 and -3, cross them off as I write them, and 6. And then I'll put my x's, x to the 3rd, x to the 7th, x to the 14th, and x to the -2. And then when I have something like this, what I like to do is clean up the numerator. So remember, this is just a total of 10 x's. This is a total of 12 x's, because I'm adding the exponents. And then when I subtract the exponents, 12 minus 10 is 2. My 2 x's are in the denominator. And then as far as this goes, you know, I'll just clean this up. And then when I do take -6 divided by 6, that's just a -1. Okay? So we either add the exponents, subtract the exponents, and in our last situation, hopefully I can get through this without the bell ringing, is what happens here. So remember, an exponent tells you how many times you should multiply something. So this says I have 3 of these. So 1, 2, 3. Which remember, this just means I have 2 x's, 2 x's, and 2 x's. So when I'm done, I have a total of 6 x's. So this says I have 2 of these. So here's 1 and 2. And again, 4 x's here, 4 x's here. And when I'm done and I count how many x's I have 8. Same thing for this one. This says I have 2 of these. So here's 1, here's 2, which means I'm going to put the coefficients together, 2 and 2, and then 2 x's, 2 more x's. So when I'm done, I have 4. Well, actually, let's not. It says do not evaluate. So we have 2 2's and 4 x's. And the last one, this means I have 2 of these. So here's 1, here's 2, which is just 5 or 3 5's, 3 more 5's. So when I'm done, I have 6 5's. And I realize I wrote really fast, but I'm trying to beat the bell. All right, so what can we do just to get straight from here to here? Well, when you have parentheses and you have the exponent, the power of a power, what you can end up doing is just multiply the exponents to get to where you want to be. So you want to keep the same base, but you want to multiply your exponents. Okay? So, and remember, what usually, in the past when we've seen parentheses, we distribute. So just think of it like that. So our shortcut is we're just going to multiply the exponents. All right, let's take a look here then. So according to this, I don't want to write this out. This would take forever. I can just distribute that exponent in and get x to the 50th power. And I can distribute this exponent in, multiply, and get x to the 21st power. And just because there's not an example of a number, let's just bring this one down and walk through it. So this 2's exponent distributes to each base. So it distributes to this base and its exponent, and this base with its exponent, which remember is a first power. And then I'll keep the same base, 2, multiply my exponents to the second power, keep the same base, multiply my exponents, and get x to the 4th power. And this is all we're focusing on right now. So the 3 rules we have covered are power of a product, which we just did, distribute that exponent in. That same rule works if there's division in there. Okay, these are common rules. Another basic rule are negative exponents. Negative exponents move. And then we have the 0 exponent rule. Anything to a 0 power is 1. So what I have to do is pause the video, and we will finish this up and look at section 7.2 a little bit more.